Okay guys, we're going to have a look at a brief tuition video here on electrolysis. So first thing I'm going to bring up here are your definitions for electrolysis. So there are, as usual, as in any of the topics that we do, so a few definitions that you need to be aware of. So there's three of them on the screen at the minute. Make sure you learn them. I'll just talk you through what electrolysis is, because obviously that's important for this topic. So it's basically the passage of an electric current through a molten substance or a substance in solution, pretty much always dissolved in water, but not necessarily always, accompanied by a chemical reaction. So in other words, what we're going to do is we're going to pass electricity through something when it's molten, i.e. melted, or dissolved in a solvent, and by doing that we're going to encourage or activate a chemical reaction, hence giving us some new chemical products which we can then use for whatever purpose we deem desirable. Now the compound that is either molten or in aqueous is a thing called the electrolyte. We're just moving on to the second definition here. So we break down the electrolyte using the electricity. Okay. And the electrolyte can be broken down because there's these things called free ions. And if you remember back to whenever we did ionic bonding in year 11, ionic compounds had free ions when molten or dissolved in water. Okay, we're then going to look at the actual apparatus that we do. And if you look here, we've talked about what's called the inert electrode. Okay, and an inert electrode is the thing that is used to actually do the decomposition. So if we look at this sort of general setup here of an electrolysis, where we have a positive electrode and a negative electrode, okay, here and here. And this is generally the way in which we break down an electrolyte. So these are our electrodes. The negative one is covered in electrons being pumped out from the negative cell of the power source, and the positive one is deficient in electrons because the electrons have been pulled away from it by the positive source of the or the positive terminal of the battery or the cell, whatever it is that you happen to be using. And it's important that these electrodes are inert. In other words, they're unreactive and they don't react with whatever substance it is, whatever electrolyte it is that you happen to be decomposing and reacting here. Now there are some electrodes that are not inert and that do actually take place in the chemical reaction, but for our purposes at the minute, anyway, until we get to the very last topic in this electrolysis of aluminium, or the purification of aluminium I should say, we will assume that all electrodes are inert. So they have to be able to conduct electricity, these electrodes, but they must also be unreactive. Okay, some other definitions then, okay, that you need to know is the cathode, which we have here, the anode, which we have here. So the cathode is the negative electrode, which attracts obviously positive ions, the sodium ion in this instance, and the anode is the positive electrode, okay, which attracts the negative ions. Now this can often be confusing because if you remember back to ionic bonding, we had the cation, and the cation was a positive ion, but now the cathode is the negative electrode, so be careful there. You have them both starting with the prefix cat, but one is positive, the ion, and one is negative, the electrode. So the best way to remember it is that cathodes attract cations and anodes attract anions. Okay, and if we look here, what we see is the general setup of a negative terminal here, which is a cathode attracting the sodium ions of sodium chloride, and the positive terminal here, which is the anode, which is attracting the negative ions of sodium chloride. And you can see that whenever sodium chloride is in solution up here, it's all mixed together, but when I put an electric current into it on a positive and negative terminal, the positive ions go one way, the negative ions go the other way, and you have now separated the sodium ions from the chloride ions, and you will make, in this particular instance, sodium metal and chlorine gas. So two very chemically useful products. So let's have a look at how this whole thing works. Okay, so what we're going to look at is the electrolysis of lead bromide. Now this is a typical example of an ionic compound. Okay, so it's clearly made up of two ions. Okay, so it is lead bromide. So the first thing you need to be able to do is to work out the formula of the compound. So it is lead to bromide. Okay, so lead 2 means that lead is 2 plus, bromine is in group 7 and is -1. So that's the formula of it. Now the second thing you have to be able to do is work out the formula of the ions. Okay, so you should know that bromide ions are in group 7 and therefore they are indeed Br with a -1 charge on them. Now it is crucial that you do not put a 2 down there because that would show that you understand that the bromide is diatomic, but it's not. What you will get here in lead bromide are 2 bromide ions. Okay, and over here we have lead, which is lead 2+. So you have 1 lead 2+ ions. So if you have lead bromide, you will have made up of lead 2+ ions, which are illustrated down here, and you'll have Br- ions, which are of course bromide ions. So the first thing that we would do here is, and it's not shown on here, but the first thing that we would do is we would heat this really quite intensely, because lead bromide is a white ionic solid at room temperature. It has to be melted. The reason for it being melted is because the ions have to be free to move, and when you melt it, okay, what you simply do is the lead as a solid is attracted to the bromide ions, hence the ionic bond, in other words. Okay, and if we just represent the ionic bond by those vertical lines, what you do when you heat it is you break those bonds. When the bonds are broken, the lead ions and the bromide ions are free to move, and this applies to any ionic compound, and they have to be free to move in order to migrate towards the anode and to migrate towards the cathode. If you don't heat it, this won't happen. The other way to do it would be to dissolve it in water. Now, lead bromide doesn't dissolve in water, but some ionic compounds, if we represent them as N and N, so metal ion, which is positive, and non-metal ion, which is negative, when you dissolve them in water, we'll just write AQ for aqueous, simply what happens is again the bond breaks and you get separate metal ions and non-metal ions. You just have to adapt your answer there to whatever the metal ion and the non-metal ion was. So that's what happens. Now if I switch on my power source, okay, what happens is that the cathode becomes a point at which electrons will build up. It becomes a negative electrode, okay, the cathode in other words, whilst electrons on this conducting rod, okay, the anode, are actually withdrawn away and they go that way. So this is electron deficient, the anode. So what happens? Well, fairly obviously, if this is negative, it's going to attract the positive ions. And when the positive ions are attracted towards the cathode, what happens is that they will pick up the electrons. So Pb, which is 2+, will go to, and this is really important, they always go to the pure element, and the pure element never has a charge. So it goes to Pb. So you'll have to work out how many electrons will this thing pick up. Well, it's 2+, it's gone to neutral charge. We never write the 0, but I'll put it on there just for simplicity purposes. Okay, so it has to gain 2 electrons. 2 negatives plus 2 positives gives me a neutral charge. Now, this thing here, at this time, the lead ion has gained, so it's going to gain some electrons, and you need to understand that that is referred to as reduction. So this reaction that is occurring at the cathode is of course reduction. Now then we have the reaction at the anode. You need to be able to work that out. Well, the bromide ions clearly are going to be attracted to the anode, okay, and this negative charge tells me they have an extra electron. So what is bromine in its pure state? Well, that is Br, of course, but remember it's diatomic, it's Br2. So what do we need to do here? Well, we need a 2 there. We cannot put a 2 down there because bromide ions are not diatomic. So what's happening here in terms of electrons? Well, remember the anode is keen to take electrons off things, okay, and pass them across to the cathode. So what happens basically is that this loses electrons. It has to lose 2 electrons, okay, so 2 minuses minus 2 minuses, okay, is equivalent to 0. So the charges have to cancel each other out. On that side it's 0 net now, and on that side it's also 0 net. And you'll see the same down here, the 2 plus and the 2 minus. There's 0 charge on the left hand side and there's 0 charge on the right hand side. So what's happening here in terms of oxidation and reduction? Well, this time we have lost electrons, and if you can remember from class, okay, loss of electrons is oxidation. Okay, and that is always the case. Electrons have been lost, therefore it's oxidation. Okay, and what does that mean that is going on in here as a whole? Well, it means that the entire reaction is a reaction called redox. You will see that referred to redox. You might be asked to explain why is this particular reaction redox. Okay, and that is a introduction to electrolysis. What you would need to do then is to, each time you get a question, is to work out what is the ions and what happens to them. So if we took, for example, if the examiner said, okay, write equations for the electrolysis of aluminium chloride. Well, aluminium is in group 3 and is therefore 3 plus. Chlorides are in group 7 and are 1 negative, as you would know. So what's going to happen? Well, the aluminium will be attracted to the cathode. And when it gets to the cathode, it will gain electrons. It will gain 3 of them because it has to turn into pure aluminium, remember, and the elemental state has no charge on it. Chlorine, remember, turns into, or chloride ions, turn into pure chlorine. Okay, therefore I need 2 chloride ions and they need to lose 2 electrons. Very simple. So this here is our gain of electrons, which is reduction. This is our loss of electrons, which is oxidation. And these equations must always be balanced. Now, the next thing the examiner might ask you is, well, what will you see? What will you see at the cathode and the anode? Well, let's go back to here. So here we will get pure silver, and it will be molten because of the heat. And what you'll see, therefore, are these very little blobs of silver. Okay, and we refer to them as silver globules. Is as good a word as any. Okay, so little molten silver globules of pure metallic lead. Over here then we get some more observations. Bromine, and because again it's warm, okay, you get brown vapour. Okay, so you get a brown vapour. Now, it's a rather stinky vapour. Okay, and the word that we use for that is pungent. Bromine is a bit like chlorine in that it smells of bleach, so you could say that it smelt of bleach. Very often you'll be asked, well, how would you identify it to prove that it is bromine? Well, you wouldn't smell it because it's extremely toxic and will knock you out, potentially kill you. So avoid that. So what you would do is take this the gas and test it with some damp blue litmus paper. And it must be damp. Okay. So that's an important word. Okay, and it will simply turn red. And it may then, but it will certainly turn red, but it may well bleach it white. And that's the same test for chlorine, okay, and the same observations. So, in other words, over here, when you're asked what would you see with chlorine, okay, you'll see the same bleachy smelling gas, okay, but it will be a different colour. It will be a green stroke yellow, or green dash yellow gas this time. Okay, will still smell of bleach. It will definitely bleach damp blue litmus paper red followed by white, and the same observation will be here for aluminium. You will, of course, it's a molten metal, and you will get silver globules of it. Okay, so in your notes there's this question here which I suggest that you do. I have the answers. So you have the cathode product, the cathode, what you would see, the observation, the anode product, anode observation, and then most importantly are the equations for what's happening at the anode and what's happening at the cathode. So what I suggest is you go through these, make sure you get the charges right, make sure you get the formulas of the products right. For example, nitride would give you nitrogen, which is N2, iodide will give you iodine, bromide will give you bromine. So make sure you don't just write Br, that the product is actually Br2. Okay, and if you can do those, you should be fine for the first part of electrolysis. And if you can do all of that, you'll be ready for the next part, which is the manufacture of aluminium from the purification of a compound called bauxite, which is aluminium oxide, which is an ore, aluminium ore, which is found deep under the earth. Okay, hope that helped. If you have any other queries, please come and see me.